Hi, this is Mr. Wharton, and I'm doing a video key for Do Now 15.1, the only Do Now of this week for pre-algebra. So if you flipped a coin 500 times, theoretically, how many times could you expect it to land tails? Well, theoretical probability is that there's a 50% chance or 1/2 chance every single time, and every single time doesn't affect any particular time doesn't affect the probability of any other time. So theoretically, we should expect 1/2 times 500 tails, half of them to be tails. So we could expect 250 tails. Would that happen in reality? With 500 flips, it probably would be close, but it would probably not actually be right on the money at 250. If you were to flip it 1,000,000,000,000 times, it's going to get a whole lot closer to half in the experimental probability, but we're talking about the theoretical probability. Now, so the theoretical probability is simply 1/2 of the number of times you're going to try it. Now, number 2A, if you rolled 2 six-sided dice, what's the probability of getting a sum of 7? Well, there are 36 possible outcomes. So that's the first thing to know. Total possible outcomes is 6 times 6, because there's 6 outcomes for the first die, and for each of those 6 outcomes, there's 6 outcomes for the second die. So it's 6 times 6, or 36. So that's the total possible outcomes. So now we got to figure out the desired outcomes. How many different ways can we get 7? Well, with a 6-sided die, you could get 1 plus 6. That would be a 7. Or you get 6 plus 1. That would also be a 7. Or you could get 2 plus 5, or 5 plus 2. Or you could get 3 plus 4, or 4 plus 3. So there are 6, and there are no other ways to get a 7 on 2d6. That's another way of saying 2 six-sided die. There's no other way. So there are a total of, let's just count them, and a lot of probability is counting. This is simple counting. 1, 2, 3, 4, 5, 6 different ways. So there are 6 desired outcomes. Okay. Okay, there's 6 different ways to get the desired outcomes, and the total possible outcomes is 36. So the probability of sum of 7 on 2d6 is going to be 6 out of 36, or 1 out of 6. So it's a 1 in 6 chance of getting that, which is why if you play the game Settlers of Catan, a 7 comes up a lot, and the robber gets activated a lot. So if you don't play that game, that's just what happens in that game. Rolling a 7 means the robber gets activated. If you have more than 7 cards, you'll lose half of your cards. And you get to move the robber around and steal stuff. Okay, so if a sum of 7 on the 2d6 was the winning roll of the dice, how many times would you expect players to win, theoretically, if you had 30 plays? Well, just like with the coin flip, how many times would you expect to get tails in 500 flips? Well, you're just going to multiply the probability of getting a 7 times the 30 times you're playing. So 1 out of 6 times 30 is going to equal 5 predicted wins by the players. Okay. Now, if you're charging $2 to play, and a player wins 5 times, if they roll a 7 on 2 dice, how can you predict theoretically how much money you would have made after 30 plays? Well, 30 plays is going to be, so just your income is going to be $2 times 30. Okay, so that's going to get you 60. However, you can expect 5 people to win. So you can expect to have to pay, and that's why the subtraction, pay $5 times 5 people. Okay, $2 times 30 plays minus $5 times 5 wins. Okay, so that's going to be 60. I'm going to put a unit in here because it's not Badgers. $60 minus $25. So you could expect to win 35. You, as the runner of the game master, can expect to have made $35. Okay, and that is the Do Now content questions. We're going to focus on the probability carnival games today and developing those. And I'm going to be talking with folks about what your probabilities are and how you're predicting the winnings. And you'll have time to just work on designing today.